Today we'll build this dimmable low-voltage ceiling fixture. Using 4 LEDs running up to 3 watts each, it puts out plenty of light, similar to a 75-watt incandescent bulb. And being low voltage, you can put these anywhere you like without calling an electrician. There's a jumper on the driver board that lets you either run these at full power, or an external PWM signal lets you control the brightness. This is a flexible design that can be made in different shapes and styles. The wood can be stained, painted, or left unfinished to suit any decor. Check the video description below for pre-made fixtures and parts if you don't want to do all the work yourself. Alright, to build this, there's several different pieces involved. There's the diffuser, there's the wood, the aluminum with the LEDs glued on, and the controller. So the first piece, let's get this out of the way, is the wood. And I used 1 5/8 by 1/4 inch. There's 1/4 inch, 1 5/8 hemlock, and then cut 2 slots with a table saw. And so the aluminum fits in the bottom slot, which will go on the ceiling, and then the diffuser will fit in the top slot. And there's a lot of different ways of doing this, but this is just a prototype. And then the next step is to miter this, and you have to cut this like a picture frame so that you can glue it together and it'll fit like a box. The next thing is the aluminum, and this is just something that's stiff, but it's flexible so that you can bend it and put it into the slots inside. So you don't want something too stiff. And what this actually is 0.032 inch 6061 type aluminum, in case you want to find it as a 0.32 inch. And this is cut to 3 inches by 4 5/8, and this is a 5-inch box, and so that's just a tiny bit short. And so you can see that it fits inside the slots that are cut halfway through on each side. The aluminum needs to be laid out and cut, and I'm going to show a way to do this with a laser cutter. There's a plastic film on here, and I use the laser cutter to cut out where you can peel the film off and glue the LEDs on, and the cover acts as a guide, and also places to drill the holes. So these are holes for mounting the driver, and these are holes for zip ties so that you can keep the wire out of the way. And then there's a couple of holes here, and I've tried experimenting on making keyhole slots, because when you put the diffuser in, it's hard to get inside the box. So it's nice if you can have a couple of screws and then push them in and slot them over. And I use a Dremmel tool for that. Once the layout is done, and you can peel these little pieces off, then we can glue the LEDs on using the special thermal conductive adhesive. This is designed for high temperature, and it's also designed to transmit the heat so that these LEDs will get very hot if they're burned at full brightness. And you want to have a good thermal path so that this actually acts like a heat sink. You don't want to use just regular epoxy, of course, because it's not designed. It'll probably fall apart if it gets hot. Once all of that's done, it's pretty much easy to just mount the driver on the using standoffs and screws and nuts and bolts and whatever, and solder all the LEDs together. And that's a pretty much simple thing. And then take some wire and screw it to the terminals. And then there's the diffuser, and a lot of things can be used for this. Anything that's opaque, translucent, that doesn't lose too much light. I got this from a local plastic shop, and it's pretty stiff, tap plastics. And this works really well, but there's a lot of films I'm sure that will work just as well, so you have to experiment. And I cut this out with the laser cutter, and I'll show that, but it's turning yellow on the side, so that tells me that it's probably not good to use the laser cutter for this. You probably want to cut it manually. And that's how it all goes together. Then this goes inside here, and then you have a completed fixture. 0.1 inch depth, and so we'll put that down here. One of these metal rulers, machinist rulers, are very handy for this sort of thing, and so just get it approximate, and then just test it on a small piece here. Exact. And we'll set this for 1/8 of an inch. And again, we'll just test that with a small piece just to check the dimensions. Now that the saw is all set, we can start cutting. Turn on the saw. And there's the double cut. The next step is to cut the miter cuts, the picture frame cuts. And so I'm going to make several of these at once. And so I'm going to try and make several cuts all at the same time. You have to engage safety squints. We'll just put this. I cut all these a little bit long so that there's going to be a little extra on the ends of each one's. And that puts a pretty nice edge on it. And then I'll do the same thing on the other side so that I have two finished edges. Just like a picture frame. Good. Now I can take 4 of these and put them together like that, and they form the box. The next step is to cut the aluminum. The LEDs will be mounted on here, and this will also form the means for attaching it to the ceiling. So I'm going to cut a strip 3 inches wide, and then 4.06, I believe, is going to be the length. So we'll just do that real quick. The width doesn't have to be so critical. This just needs to be wide enough for the LEDs to form the square. But the length is very important because it has to fit into the slots when the box is glued together. And there's the plate. Here's the 4 pieces of wood that's going to make the box. As you can see, it would be kind of hard to glue these as is. My father had a bunch of these clamps. They're Sears Craftsman corner clamps. They're not the ideal thing because they don't press into the joints, but they'll be good enough for an experiment. So what I'm going to do is take 2 of these pieces and clamp them in like this, and then I'll take 2 of these and then glue them together. So we'll get to that. First of all, we want to clean up some of the edges. Just use a rasp file or sandpaper. So what I'm going to do is put some glue on both of these joints. And like that. Make a big mess. Mmm, yummy. And then stick them like that. And then that goes in there. And the trick, got a piece of wood here to, the trick is to press the joint together, but this clamp doesn't really allow for that. So this clamp is really designed just to keep things straight, which is good, but it'd be better to it's all set up now. It's been overnight, so let's take this apart and see how it looks. Great. Oh, that was smart. Okay. You learn. Is that the one that went together nice? Yeah. I'm just using the paper so I don't make a mess on the bench. And this time I'm just going to use rubber bands because they'll put pressure on these joints, whereas the box is the joints are pretty weak now, but once they're all four glued together, they'll be a lot stronger. Now that the wood is out of the way, we can work on the functional part of the lamp. So here's the aluminum that was cut earlier, and it'll end up like that roughly. And the idea is to take 4 LEDs and glue them in a circle, or a square rather, like that, so that when the lamp is on it, the light will diffuse out this way. Then we need a current controller or power supply. And this is my Mason 2 power supply that will take in 12, I forget how high voltage, but you can hook this up to 12 AC or DC, and it can take a PWM signal and then drive all of these LEDs. And then there needs to be some holes for mounting, and there needs to be some holes to be able to put a zip tie through so the wires don't get in the way of the LEDs. And I was thinking I could get out the layout tools and start scribing and marking and everything else, which is a kind of an individual, you got to do this for each one. And so I was thinking there's got to be a much better way to do this, a template or something. And I have an idea for that. This is known as a K40 laser cutter. It's a popular model these days. You can find out more information on them by web searching K40 laser. So what I'm going to do is first put some paper inside, and then I'll cut the pattern on the paper so I know where to place the aluminum. I just don't want it moving once the pattern is cut. Then you don't want it to move, so you have a reference. Now that I have an outline, I can put the plate right on the outline and get it as accurate as possible. And then laser engraved. Now this could be PVC plastic on there, and that's not very recommended because it's poison gas, and it'll corrode, the gas will corrode things, and but it's very thin. And this is an experiment. It would be much better to put some like post-it material, like a large post-it, peel the plastic off and put a post-it on, so you're cutting paper, not some unknown plastic. But that seemed to work pretty well. Now I just need to punch it so I can drill out the holes, since my laser isn't that strong. Happen to have a random piece of steel here. Now that the holes are drilled, it's time to glue the LEDs. And first, peel off this bit of plastic here. So now I got to get the thermal epoxy out. And as a friend of mine asked, you don't want to use just regular epoxy, because first of all, it probably may break down with high temperature. So it's not designed for high temperature, which this is. And also this will transmit heat, whereas regular epoxy may actually act as an insulator. I squirt out a nice little bead and then pull this back to draw pressure, try to pull some of that epoxy back in. Just trying to get equal amounts. It's not too sensitive, I don't think. This is the one that 80 degrees centigrade for 1 hour is all it needs to bond. You just want a uniform coat. And I'll stick one of these on, and see, it's very easy with the plastic acting like a guide. And so in all cases, I want the negative terminals on the outside. As I said in the last video, it's easy to scrape off the epoxy if you get somewhere where it doesn't belong after it's set. That should do just careful inspection. Just make sure all the positive terminals are on the inside. Alright, I think I'll clean that off camera because it's a little difficult. But that's the idea. Now it's time to bake it, and I'm going to use the reflow oven to do that. I almost forgot one very, very important point. Can't bake this with the plastic on there, or it's going to melt and make a big mess. So now it's time to pull the plastic, now that all the holes are drilled and the LEDs are placed. And this is the favorite thing of some people, peeling this kind of thing off. And on the back too. This is just protective film to keep the aluminum clean when you're in a shop with oily things around. Now it's ready to bake. This is my reflow oven setup, normally used for solder reflowing, and it can also be used for baking. I'm still using the older Control Leo, though Wizzo now has a new version with the touchscreen. So now all we have to do is making sure that there's no plastic on this. Put that in the oven. and start baking. And you can see how it cycles. Each LED is a different element, and then this is the convection fan. So you can see how it heats up, and it doesn't start timing until it gets up to close to the temperature. Now that it's all glued, it's time to solder the wires. There's several ways of doing this. One is to use solid wire with sleeves, and another way is to use Kapton tape. And so I'm going to experiment and just cut some tape and then put the wires over the tape. Just trying to think of ways to do this without a lot of assembly time. It is a little messy because on camera it's just a little difficult to do precision work when you're also on camera, but just experimenting. And then what I'll do is put some Kapton tape over the wires. We'll bring out the good old heating plate. And turn it on just to get it hot to the touch, and then unplug it so it's not going to be too hot. And turn on the soldering iron and tin the pads. This time I'm just going to use bare wire and then tape it down with Kapton tape. Now it's hot to the touch. I'll unplug it. When soldering LEDs like this with heat sinks built in or bonded to heat sinks as here, it can be difficult to solder them at room temperature. Using a hot plate brings them closer to soldering temperature. You want to leave some slack because you don't want the wires to stretch when there's a thermal expansion. So I'm going to put a kink in it. Put some flux on there. And what I'll do is put a twist in like this to keep that connection out of the way. And then if there's thermal expansion, it has some slack there to keep that away from the bare metal. This is the same connection, so it doesn't matter if it's touching that. So there's a ground connection. Bend this one up so that it's up out of the trouble. Just tin these to make them easier to go in the connectors. These are 440 screws and 632 threaded spacers, but the screws go in there okay. They're a little bigger than necessary. Fix that some other time. Stick that in the plus. Next, I'll plug this into a DC power supply. This CAT 4101 chip will take up to 25 volts on DC, but there's a rectifier here. So probably about 18 volts is if you're using AC. Of course, the polarity doesn't matter because there's a rectifier there. And this jumper, if it's on the right side, will make the LED run in PWM mode using the PWM connections, either these two pins here or these two screws here. And if you move it to this side, then it's just on completely, so that we can use that for testing. So that it doesn't swamp out the camera, I'll just cover it lightly with some heavy paper. And that looks good. You can get these PWM controllers on eBay cheap. So this is really for a motor, but this will work to test this. I just soldered the wires on the back because these things are terrible. Just be aware of that if you buy these cheap controls. So I'll take the 12 volts off of here and connect it to here. And I got it all connected. And I'll just flip this. First of all, I have to move this jumper over to the PWM side. And I'll flip this over so it doesn't swamp the camera. Now to put it in the wooden box. I loosened the screws up a little bit here. And now I'm just going to press it in. And there's a complete unit. I just put some hot melt glue in to hold this in place. We'll let that cool for a second. For the shade, I found this material at the local plastic shop, and it's got a very interesting pattern, but anything can really be used. It just needs to be flexible enough to where you can bend it and get it worked in there. So what I'm going to do is cut off a rough piece of this, and then I'm going to use the laser cutter to make a precise cut. As before, I taped down a piece of paper so that can serve as a guide, so I position the plastic accurately according to where it's going to cut. So I'll hit the power and we'll cut a pattern. So I have that set to 50% and an 80 millimeters per second, and I'll run that. Now I'll put the plastic in and make sure that the line is not showing. Put a weight on there. Now I'm going to close this and turn on the fan because this is going to be stinky. Let's see how this came out. Now this film can be placed in the slot here, which can be a little fiddly, so it'd be good to find a better method to do this. To mount this fixture on your ceiling, use 2 flathead wood screws and space them 2 inches apart. A quick recap: the wood and aluminum were prepared, the wood was glued, the back plate was done using the laser cutter, LEDs were glued on and soldered, and then the final assembly, and the all-important testing, and then finally adding the diffuser. I hope you find this project useful, or at least entertaining. Completed lamps and parts are available through the website below in the video description. Customized versions may also be available as time permits. Contact information is below. Please leave a comment, since this will help make future videos better.